Hi everyone. So today I'm going to design a very simple neural network from the scratch. So in today's lesson, what I'm going to do is, before that, just want to let you know that this video is for people who have done some kind of background research about neural networks and artificial intelligence. So if you have watched videos about different neural network models, how we train these neural networks, I'm not talking about the in depth, but if you have watched few videos like how you have how we train neural networks, how these neural networks work in basic way. So if you have that idea in your mind, then this lesson will be very easy to understand for you guys. So right, so in today's lesson, I will be doing a forward pass for our neural network, and based on that forward pass, we will be calculating the error. We will be calculating the error, and based on that error, we will calculate the loss, and based on that loss, we will be calculating the derivatives, right? So based on that derivative, we will be doing the gradient descent, and so during that gradient descent, we will adjust the weights using the learning rate. So that's what we are going to do basically. So for this neural network, I'm going to choose a very basic formula uh, in machine learning, which is called the linear regression, right? So the loss function I'm going to use for this demonstration is mean squared error. So those are the things that uh, I'm going to explain you. So without wasting time, let's start the video. So in this video, I'm going to show you exactly how a neural network learns with real numbers and real maths. So in here, no magic and no shortcuts in this video. So we will use the simplest possible network. So it has like one input, one weight, one bias, and one output. So basically what I'm going to use is here the linear regression model, right? So that's the model that we are trying to explain you. So if you don't know about linear regression and basic neural network concepts, I think it's better to watch few basic videos and then come back to this video. Then it will be much helpful for you to understand this video, right? So let's draw our small very tiny network in here. So right, so here this will be our input, and this is our neuron, and this is our output, right? So in here, in machine learning and artificial intelligence, we usually mark this input as x, right? And we usually mark this output as y hat. uh, Y hat means the prediction. So in a neural network, the output is always the prediction, right? So here I will draw the weight. W means weight, and here in here, uh, let's say this is the bias, right? So if you have watched many videos about neural networks, and likewise, uh, you may have come across that there are concepts, or there are things called activation functions, but in this explanation I'm not going to cover the activation function. since this is a very basic explanation on how a neural network learns, so I will not cover the activation functions, but in later videos we will cover that. But to understand the concept, this is more than enough, I think. All right, so this will be our visualized network. So let's write the formula, right? So this will be our formula, wx plus b. So this is the formula, right? So this is the model, right? So now what we are going to do next is we are going to assign some dummy values to these variables. So let's say input is our input is 2, right? And y is 10. So what do you mean by y means the real number, right? So here without just putting the numbers into these variables, let's take a small example. So let's try to predict house prices, right? So just assume that we are going to predict house prices using this linear regression model, and x will be the input. So for now let's assume x equal to, and y is the real price, right? Let's write that real price. Y is the real price, and let's say weight is 3. So we have allocated weight as 3, just a random number. And after that let's say weight as 3, and bias is 1. Right? So these will be our random numbers, right? And hope you have already learned about learning rate. So for this example, let's take the learning rate as 0.1. So this is the rate. So once we find the derivative of our loss function, so this will be the rate that we are going to adjust from our real weights and bias, right? So this is the learning rate, right? And now so this formula is the heart of the network, so I have already explained that, right? And now let's go to the next section. So what I'm going to do in next section is I'm going to do a small forward pass. So in a neural network, what do you mean by forward pass is we introduce some new inputs to the network so we can train the network, right? So let's assume we input this number 2 to the network, this 2 to the network, right? So right now our weight is 3, so here 3, and bias is 1. We don't know what is the predicted value, right? So now we are going to do the real calculation. So let's do the forward pass. So since our formula is wx plus b, we will substitute the values, right? So w means 3, right? X means 2, plus bias is 1. So the answer is 3 into 2 is 6, plus 1 7. So the predicted predicted output is 7 right now, right? So we have done a forward pass now. Now if we summarize this, our predicted value is 7, but our real value, so our real value is real value is 10. Our real value is 10, right? Real value is 10, and the difference between that is minus 7 minus 10 is 3. So we always, to get the difference, what we always do is we subtract the real value with the predicted value. So that's how we get. So the minus 3 means our the predicted value is 3 below than the real value, right? So that's the meaning. So here the network predicted 7, but the real answer is 10. So we are so in here we are wrong by 3. So our prediction, so say for an example, the input is like square inches. So let's say we have input the network that 400 square feet house is $5,000, right? So the network predicted 400 square feet house is $5,000, but when we initially try to initialize all these weights and bias, and if we initially run this neural network, we get a value as $3,000, right? So the predicted value is $2,000 below our real value. So that's what it means, right? All right. So now in here what this minus 3 means is how wrong we are. Sorry, not how wrong. We are wrong by 3, right? So we are wrong by 3. Now we need to measure this mistake properly, right? So just saying we are off by 3 is not enough, right? We need one number that tells us exactly how wrong we are. So that's the key point. We need to find how wrong we are. Right? So then you might ask from me, so minus 3 is the value which represents how wrong we are. Yes, I understand that, but in here how wrong we are is the term. Why we have used that is of course minus 3 has that meaning also, but what if we have done something like this? What if we squared this error, right? Then the minus value will get cut off, right? And this will be 9, right? So if we square this answer, then we can clearly see the impact. So say for an example, if this is a very small error, let's say 0.1, then if we square it, what will be the answer? So if it is a small error, you can see the how wrong VR value is also very small. But if the error is getting bigger, so this represents how wrong this error is, right? And also uh, so that's the basic idea. So in addition to that, and also this will help us to correct our loss function. Okay, so you will understand this later. Just for now, just keep in mind. So in here, so our aim is to find how wrong we are, right? Okay, now let's come to this our new topic, that is the loss function. This is not the new topic. This is the same topic that we discussed here, how wrong we are. So in here, the loss function measures how wrong our prediction is, right? We use a formula called mean square error. For short, we can say MSE, which is mean squared error, right? So there are different kind of loss functions. Say for an example, there is a loss function called mean absolute error. So in that loss function, what we do is we are doing something we have discussed in here, right? So this -3, so we take the difference or the error as -3, and what we do is we directly cut off this minus or the plus part, basically the minus part, sorry. So then it will become just the 3. So there are loss functions like that. But if you have time, just refer some tutorials about these loss functions. So in this mean absolute error, there are some downsides as well, because uh, when we are doing the gradient descent, this when we use this loss function, no matter how small the uh, loss is, so this will tend to reduce the error more than what we need, right? So if you have time, just refer that. But for today's example, we are using this mean squared error. So this is the loss function that we are taking. So in mean squared error, what we do is, if the error is let's say 4, then what we do is we square that error. So basically loss function is MSE, mean squared error loss function, means square root of our error. So that's the mean squared error in simple terms. Right. So loss function, so we can write loss function like this: y hat minus y into 2. So here I think you already know these values. So y hat means the prediction, and this is the real value. So in our previous example, our prediction was predicted output was 7. Predicted output was 7 and the real number was the 10, right? So we got minus 3 and we have squared it. So we got 9. So this is our loss function, and this is the result we got, right? Okay, now we were able to calculate the predicted value, and we have found the error. So error is the minus 3. So which means we are wrong by minus 3. So in order to find the how wrong we are value, we are using this mean squared error function. So using that mean squared error function, we calculated the 9 as the loss. So this is the loss, right? 9 as the loss, right? So up now, hope you are clear. If you are not clear about that, please do comment below, then I will answer it. Okay, now what we are going to do is, now we are going to find the derivative, right? So derivative means, so you can see that loss function has a common graph. So if we take the loss function, it means error squared, right? Squared of the error. So if we plot a graph, this function's graph looks something like this. If we take loss to the y-axis and here the weight, so this is how our loss function will look like, right? So in here, say for an example, since our loss is 9, so let's say the loss is 9, so our loss could be somewhere around here or maybe here, right? Okay, now we need, so our goal is to somehow take this loss all the way down to this 0. So if we get a 0 loss, that means our neural network will provide us the perfect prediction. So if we want to reduce this loss, we need to find which way we need to adjust this loss, right? Which means if we increase the weight by very tiny amount, we need to check how much the loss will change. Say for an example, like this. So this is our goal, right? This will be our goal. So in here, what our goal is, if we increase our weight by a very very tiny amount how much the loss will change, so that is the that is our goal, right? So you can see, to achieve this goal we need to use derivatives in maths. So if I write this in maths, we need to find dl or dw. So this is what we need to find. So we need to find, if I increase very little amount of w, how much the loss will change, right? And our function is this. So we need to find the derivative of this, right? So we need to find the derivative of this one. Right, so you can see that if we want to find a derivative, right, okay, so if we want to find the derivative, we need something with w, right? I forgot the name, but we call that in maths. Wait a minute, I'll refer. It's like this. What we call here is we are finding the derivative with respect to w. So that's the word, right? We are finding the derivative in respect to w. We are going to find the derivative with respect to w, right? So as you can see here, y minus y. So in here we cannot directly see a connection with w, right? But in order to find the derivative, we need to somehow find the connection with w. So if we closely look at here, what is this y hat? Y hat means the predicted output, right? So how does this predicted output come? It comes with this formula, right? Our linear regression formula, wx plus b, and y is just our real output. So if you write this formula in another way, so this is how we write it. So we can write wx plus b minus y square. So now we can easily find the derivative, right? So in order to find the derivative, so as you can see, you need to use what you call in maths, you need to use the power rule and the chain rule both, right, to find the derivative of this. So using the power rule, let's take the 2 out and let's write this like this way. And after that let's differentiate what's inside, right? So this is the outside derivative, outside. So this is the outside, and we'll take this part and find the derivative. So as you know, in here, if you take this wx, the derivative of wx is x. Why is that? Because if we closely look, x is with the w, right? So if we write this in another way, x into w, so you know how to use power rule. So if we say w, that means it has a power of 1. So if we subtract 1 from it and if we add 1 here, x into w0, so w0 means 1 into x means answer is x, right? And if we take the b is plain number with no w in it, so here, so its derivative is 0, and same for the y as well, its derivative is 0 too. So we add all three results. X plus 0 plus 0 equal to x. Right, so now, so this is the inside, right? Inside. So now we have inside and the outside values. So using the chain rule, so what the chain rule tells is we need to multiply the inside with the outside, right? So now what we are going to do is we are going to multiply to find the derivative of dl we will multiply this value with this value into x, right? So this is the derivative of loss function that we have discussed above. Right, now let's plug in some real numbers to this to this formula, and let's substitute x equal to, you already know that, and our w is 3 and the bias is 1 and the real value is 10, right? So our derivative answer is minus y into x. So here what we do is plus 1 minus 10 into 2, 6 plus 1 minus 10 into 2, 7 minus 10 . So this is our answer. So this is our derivative, right? So this is our derivative. Right, this is our derivative, right? So what this means is, if we change small amount of weight minus 12 amount of loss will get reduced. So that means in other words, if we increase the weight by a small amount, then our loss will get reduced by 12. So that's its meaning, right? Right, now we'll keep this minus 12 in our mind. Now let's move to the next section. So in the next section, so we have already calculated the derivative for the wx, but remember, in our main formula there's another variable called b, right? We have already found the derivative for this, but there's another part called b, so we need to find the derivative for that also. So we do the exact same process for the bias, right? And same formula, same steps. The only thing that changes is we differentiate with respect to b instead of w. So remember, we have differentiated this with respect to w, but if you want to find the derivative of b, we need to differentiate it with respect to b. So that's the only difference. So we'll take the same loss function So if we write y hat, which is predicted as another way, wx, right. So this is a loss formula which you already know, that which we are going to find the derivative with respect to b. So let's start. So using the power rule, let's find the outside derivative. 2 into wx plus b minus y, right? Then we'll take the inside. So in here, wx has no meaning for this one, so because it is a constant, right? Because we are not finding the derivative with respect to w, we are finding the derivative with respect to b, no, so there's no value for wx. The derivative of b is 1, because if we find the derivative here, it's b to the power 0, which is 1, and minus y also same, there's no use, it's 0. So the inside derivative is 1. So now let's apply the chain rule. Which chain rule? What we are going to do is we are find the loss with respect to bias, right? B. One into 2wx plus b minus y. So this is our derivative with respect to b, right? So this is our derivative with respect to b. Now let's plug in some real values and see what will be our derivative, right? So as you know, our x value is 2, our w value is 3, w value is 3, our w value is 3, and our b is 1, and our predicted value is 10. Now let's see. So here the derivative is minus 6, which means for a tiny increase in bias our loss will change in a minus 6, which means loss will reduce by minus 6. Loss will reduce minus 6. Loss will reduce by 6, right? So that's why it's called minus 6. Right, now we have everything what we have to adjust our weight and the bias. Right, now what we need to do is just take our learning rate and multiply it and reduce the weight and bias. That's what we are going to do next, which is our final step. So our final step, we call that process a special name that is called gradient descent. Which means updating W and B. Actually, we know which direction to move W and B, right? So that's we have finding the derivative of W and B, right? Sorry, not W and B, with respect to W and B, the loss, right? Okay, so we use the formula called the gradient descent to actually update them, right? What we do is we are not going to directly reduce this amount from our weight or the bias, because it will if we do that, what will happen is then we will be able to see huge spikes in that loss function, right? So we need to gradually one by one very slow steps to reduce that error. So that should be our main goal. So to achieve that main goal, we are using something called a learning rate, right? We represent it as alpha. The learning rate. So the learning rate controls how big that step is. Usually we use 0.1, because if we use something bigger value, then we will overshoot it. So let's assume, as I have explained earlier, learning rate is 0.1, right? So in order to update our new weight and new bias, what we do is, if we want to predict our new weight, we take our old weight and we deduct it by the what do you call, the derivative of loss function with respect to w with our learning rate, right? Same method for the bias as well. Old bias minus with respect to bias b. So in here you might ask why we subtract, because we subtract because actually when dl into dl over dw is negative, subtracting the negative makes the weight go up, and we just saw that we need uh, weight to go up, right? When dl over dw is positive, actually subtracting the positive makes the weight go down, right? So this is always correct, and the formula automatically moves the weight in the right direction. So if we update our new weight, so this is our formula. So we already know these answers. Old weight was 3, 0.1 is our learning rate, and minus 12 is our derivative. Zero point 1 into minus 12. Let me use my calculator because I'm a little bit bad with these calculations. Minus 1 2 3 plus 4.2. So this is our new weight, right? So this will be our new weight, and let's update the b as well, which is the bias. Update b. So let's take the b new. And we substitute the values. B was always 1, 0.1 into minus 6. Yes, minus 6. So our b new value is 1.6. So now we have our newly predicted weight and the bias. Now let's plug this value to our linear regression model and see what will be the prediction, our new prediction. So our new weight is 4.2 into 2, 1.6. 4.2 into 6 was 8.4 plus 1.6, 10. Wow. So you can see our uh, predicted value became the real value. So this is a very uncommon thing, but if this happens while learning, then it will be a big achievement. So which means our predicted value is same as the real value. So this network has done its training really good in one round. So usually, in order to achieve some kind of accuracy for a model, it depends the number of rounds. Say for an example, at least we need couple of 100 rounds to 1000 rounds, but in here we just achieved it with one round. Do you know why? Because actually I pre-calculated these figures for ease of explaining you. That's why, right? So that's the honest reason. So anyway, now I think I have covered almost everything. So this process of so once we predict the output, and based on that output we calculate the error, and we see how wrong we are using the loss function, and the effort of uh, reducing the loss, we call it the gradient descent. So this entire process after prediction, the entire process of reducing the error is uh, entire process of reducing the error and adjusting the weights and bias is called the back propagation, right? So that's what we have done after predicting the output, right? Right. So finally, if we draw another simple graph with loss and training outputs, because remember I told you earlier just a while ago that this kind of loss will not become zero at once. The neural network has to go many rounds to achieve that, and most of the cases it won't achieve this zero target, right? So this is how this graph looks like. So the more the training rounds are, then the loss will get gradually decrease. And you can see in here, after some rounds, conducting more and more rounds is not necessary, because it will not make much difference, right? And I think that's it. So that is how a neural network learns. So if you have any comments or suggestions, so if we found any mistake in my video, please feel free to comment in the comment section, so I will try my best to answer. Thanks a lot for stay tuned with me. Have a nice day.